In previous two parts, we discussed about the Fourier series of periodic function, where we understood Fourier series is nothing but synthesis of periodic function when that periodic function satisfies Dirichlet's condition. And Fourier series is combination of terms of sine as well as cosine. In this module, we are going to collect all those formulas required to find Fourier series expression for any periodic function. This classification is done with respect to the range in which that periodic function f of x is defined. So we start with the general case. We consider f of x be the periodic function with period twice L, and f of x is defined in the interval say c to c plus 2 times L, or we can represent it as x belongs to the interval c to c plus 2L. Since f of x is periodic function with period twice L, and if it satisfies Dirichlet condition, then the Fourier series expression for f of x will be a0 upon 2 plus summation, where n varies from 1 to infinity, an into cos n pi x upon L, where this cos n pi x upon L is a periodic function with period 2L, and the second term is bn sin n pi x upon L. So this is the required Fourier series expression for the given periodic function with period twice L, where the Fourier coefficients a0, an and bn are evaluated by using the Euler's formulas, where a0 is equal to 1 upon L. Integration is calculated in the given range, which was c to c plus 2L, an integration of function f of x with respect to x. Then the second Fourier coefficient an is evaluated by using formula 1 upon L into integration from c to c plus 2L f of x multiplied by cos n pi x upon L, and take this integration with respect to x. Similarly, bn can be evaluated by 1 upon L integration c to c plus 2L of function f of x multiplied by sin n pi x upon L, and take this integration with respect to x. So this is the general case to find Fourier series of function when period is 2 pi and interval is c to c plus 2L, where length of the interval is twice L. We consider case 1. If f of x is periodic function with period say 2 pi in the interval 0 to 2 pi, then we can compare it with the previous case. Here we can find value of twice L is equal to 2 pi implies L is equal to pi, and instead of interval c to c plus 2L, here value of c is equal to 0, then the interval will be 0 to 2 pi. Therefore, required Fourier series will be f of x is equal to a0 upon 2 plus summation n varies from 1 to infinity an into cos. So first we consider the initial formula, that is n pi x upon L, where L is equal to pi. So we can cancel this pi. So the simplified form will be nx only. Same is the case with bn into sin nx. So this is your Fourier series representation for the periodic function f of x when its period is 2 pi. Now let's discuss about the Fourier coefficients. Here a0 is evaluated by, if we recall the previous formula, the first term is 1 upon L. Since L is equal to pi, so we start with 1 upon pi integration in the given range, that is 0 to 2 pi, the original function f of x, and take this integration with respect to x. This is our value for first Fourier coefficient, that is a0. Then we can find value for an in the same fashion, 1 upon pi integration in the range 0 to 2 pi, take the function f of x multiplied by cos nx into dx. Bn is equal to 1 upon pi integration 0 to 2 pi f of x into sine nx dx. Here if we observe the Fourier series, since f of x is periodic with period 2 pi, then on the right hand side cos nx as well as sin nx, these are periodic functions with period 2 pi. So this is our formula. Now we consider if my f of x is periodic with period 2 pi, but it is defined in the interval minus pi to pi. So we consider the case 2. If f of x is periodic function with period 2 pi and it is defined in the interval minus pi to pi. If we observe this interval, length of this interval is 2 pi. Then if we consider the graphical representation somewhere here, say it is minus pi, this is pi, and in the middle we are getting 0. So depending upon the nature of this interval, here we have 3 cases. Case 1, if f of x is even function, then ultimately we get Fourier cosine series. If f of x is odd function, then we get Fourier sine series. But if f of x is neither even nor odd, then we have to use the general formula. So we start with the general case. Let us assume this f of x is neither even nor odd. Case 1, f of x, then the Fourier series representation will be a0 upon 2 plus summation n varies from 1 to infinity an into cos nx plus bn into sin nx, which is similar to the previous step. Now most important part is the Fourier coefficients. So since value of L is equal to pi, so we start with 1 upon pi integration minus pi to pi, take the function f of x, integration with respect to x. We consider an is equal to 1 upon pi integration minus pi to pi f of x multiplied by cos nx integration with respect to x, and bn is equal to 1 upon pi integration minus pi to pi f of x multiplied by sin nx, and this integration with respect to x. So this is the general case. Here we have considered the original interval minus pi to pi. Now the main task while solving these integration is when you have even function, say f of x is even function, then integral of this form for even function is always 2 times integration 0 to pi f of x, and if f of x is odd, then this integral will be 0. So by applying the integral properties of odd and even function, then we get the remaining 2 cases, which are, suppose f of x is even function, then the Fourier series will be f of x is equal to a0 upon 2 plus summation n varying from 1 to infinity an into cos nx. So this is the Fourier cosine series when f of x is even function, where value of these Fourier coefficients is calculated by integration 1 upon pi. Since we have started with minus pi to pi and f of x is even function, by applying integral properties of even function, this integral can be written as 2 times integration 0 to pi. Similarly, an is equal to 2 upon pi integration 0 to pi f of x into cos nx, and this integration with respect to x. Since f of x is even function as well as cos nx is even function of x, product of two even function is always even. Therefore, by using integral properties of even function, we can rewrite that integration as 2 times 0 to pi instead of minus pi to pi. And now if we consider what about Bn? So since we were calculating integration from minus pi to pi and product of f of x since it is even with sin nx since it is odd, product of one even, one odd function is always odd, and by using integral properties of odd function in the range minus pi to pi, this value will be equal to 0. So there will be no term containing Bn, means there will be no term containing sin nx in the Fourier series. Therefore, this is our Fourier cosine series when function is even function. Same is the case with odd function. So case 3 will be if f of x is odd function, x is defined in the interval minus pi to pi, then the Fourier series for this odd function will be summation n varies from 1 to infinity bn multiplied by sin nx only. And this is the Fourier sine series where value of bn is evaluated by the same formula as that of previous case, 1 upon pi integration minus pi to pi f of x multiplied by sin nx. Since product of both odd function is always even, then this integration instead of minus pi to pi will become 2 times integration 0 to pi. And this is your formula for Fourier coefficient Pn, and the same integral properties if we apply for that odd function, value of a0 will be 0 as well as an will be 0. So this is your Fourier sine series when function is odd. This is one case. If we consider the next case, if your function is periodic, moreover it is a trigonometric function with period 2 pi where x is defined in the interval 0 to 2 pi, then we check whether f of x, which is trigonometric in nature, whether it is odd or even function in the range 0 to 2 pi. Since if we consider the sign conventions of the trigonometric function, in first quadrant all trigonometric functions are positive, in second quadrant only sine is positive, in third quadrant tan and inverse of tan is positive, and in fourth quadrant only cos and its inverse is positive. So in the range 0 to pi, sine is even function, cos is odd function, then integration from 0 to 2 pi for cos will be 0. So for trigonometric function we have to take care of the signs and then decide whether that trigonometric function is even function or odd function, or it is neither even nor odd. Depending upon the case, find values of the Fourier coefficients and get the Fourier series. So these are some standard formulas that you should remember before solving examples. So hint: to find Fourier series of any f of x defined in any interval, always start with the range, that is the interval. That interval will tell you which method of solving is to be applied. If your function is not trigonometric and range is 0 to 2 pi, then we have to find all three Fourier coefficients and we need to evaluate those three integrals. If your range is minus pi to pi, then we need to check whether f of x is even function, odd function, or neither even nor odd. Depending upon the case, apply the formula and evaluate the Fourier coefficient like this. I hope you recalled all the formulas. So just collect all those formulas together and let's try to solve some examples.